All right, today we'll be doing some sort of complex exponent problem solving to showcase a variety of problems and techniques for those problems that you might commonly see on assignments, worksheets, tests. Basically, everything to do with exponents in math class. So let's start with some, relatively basic ones. Let's say I have a problem that asks me, okay, 3 to the 2x equals 9. What is x? So in these types of problems, I always want to convert, if I have an x in the exponent and I'm solving for whatever x is, right? I always want to convert this base to this base, right? I want to make sure that these two bases are equal, preferably making this in terms of this base, right? So 9 happens to be 3 squared, right? So I can say, okay, 3 squared equals 3 to the 2x. And here I can say, okay, I want for these to be equal, right? For these to be equal, I want these two exponents to match. So I have 2x equals 2. I can divide by 2. X has to be 1. So my answer is 1. And that's how I solve it. It's another solve. Now, these types of problems can oftentimes get more complicated. And we'll do one such more complicated one now. Let's say we have something like 5 to the 3x plus 2 is equal to 25 to the x minus 1. Now here, it's a little difficult, but I want to keep things as simple as possible. So I want to convert 25 in terms of 5. 25 is, of course, 5 squared. So I have 5 to the 3x plus 2 equals 5 squared all to the x minus 1. Remember, the power rule of exponents says that I can multiply this out. So I'm going to multiply x minus 1 by 2, and I have 5 to the 3x plus 2 equals 5 to the 2x minus 2. Once again, since these are equal, this has to equal this. So I have 3x plus 2 equals 2x minus 2. I want all my x's on one side, so I'm going to subtract 2x. I'll have x plus 2 equals negative 2. I want all my 2's on the other side, so I'm going to subtract 2. And I have x equals negative 4. Just like that, I've solved it. Let's do another more complicated one. Let's say I have something like, it's not fully erased. Let's say I have something like 1/4 to the x minus 1 equals 4 to the 2 minus 3x, right? Right off the bat, this 1/4, it's an outlier. It's weird. I want to get it in terms of 4 because that's just really weird. But I notice, if I remember my rules for negative exponents, 1/4 is actually the same as 4 to the negative 1. So we have 4 to the negative 1 to the x minus 1 equals 4 to the 2 minus 3x. Once again, I use my power rule to distribute that negative 1 out to x minus 1. So I have 4 to the negative x plus 1 equals 4 to the 2 minus 3x. Since these are equal, this has to equal this. I can set them equal to each other and solve. I have negative x plus 1 equals 2 minus 3x. I want all my x's on the same side. I'll add 3x here and subtract 1. And I end up getting 2x equals 1. I can divide by 2. And I get x equals 1/2. And boom, there, I just solved it again. And again, we went down the path of, okay, saying, where's the outlier, where's the weird thing, how can I simplify that using my rules, and this doing our standard exponent rules to solve that. But let's get into something a little more tricky that often shows up, where you have to use different rules. Let's say we give a problem where we're asked, what's 8 to the 2/3? What does that equal? This is a really weird thing because fractional exponents. Well, what does fractional exponents mean? First thing I'm going to do is I'm going to rewrite this as 8 to the 2 times 1/3. Right? And now we can do that because of the power rule, right? Multiply together, get 2 times 1/3, that's 2/3. So 8 to the 2, of course, we know is 64. So we have 64 to the 1/3. What does that mean? What does a fractional exponent mean? So let's think. Let's try something else. Let's do 1/2 because 1/2 is easier, right? What's 9 to the 1/2? Well, one thing I notice is if I then multiply 9 to the 1/2, I add them together, I get 9 to the 1. That means that 9 to the 1/2 must be the square root of 9, since I have to square it, multiply it by itself 2 times to get 9. What about 9 to the 1/3? Well, I have to multiply by itself 3 times in order for me to get 9 to the 1, in order for these to add up to 1. So that means that 1/3 is the cube root of 9, and 1/2 is the square root of 9. And we can generalize and say, okay, well, if I have 1 over a number n as an exponent, that's the same thing as the nth root of a, right? So in this case, if we want to go back to our original problem, what we really have here is, okay, what's the cube root of 64, right? And we know that 64 is 4 times 4 times 4. That's 4 cubed. So the cube root of 4, because the cube root of 64 is 4. That's our final answer. Let's get some more practice with these fractional exponents because they can be pretty tricky. Let's say I have something like 9 to the 3/2. Once again, we're going to break this up into 9 to the 3, the 1/2. Or we can say, oh, 9 to the 3, that's a pretty big number. I don't want to do that. So we can instead write it as 9 to the 1/2 times 3. Since once again, we're allowed to do that by the product rule. 9 to the 1/2, we know that's just the square root of 9 to 3. Square root of 9 is 3, so I have 3 to the 3. I know that for a fact to be 27, and boom, there I go, just solving my problem. And that's the basics of dealing with fractional exponents, which show up a lot in different types of problems. But now let's go over to even further advanced problems. Let's see, how about something like, what do you want to do? We can have 3x minus 2 equals 1/3 negative 2x. Now this here is a real tricky one. We got a lot of stuff going on. First thing I want to do, make sure I can have matching bases. And 1/3 is weird, so I'm going to use my negative exponents law to rewrite that as 3 to the negative 1. So I have 3x minus 2 equals 3 to the negative 1 times 2x, right? So I can do my product rule there, multiply them out. That's 3x minus 2 equals 3 2x. Since we're equal, the exponents have to be equal. So I'll just set them equal like this. X minus 2 equals 2x. I have x equals negative 2. Boom, I can just solve my problem just like that. So let's end with a real complicated problem. A real big one, if you will. So we have 5 to the 3x plus 2 minus 1 minus x, very, very long exponent, equals 125 to the 2x minus 1 minus x. Now don't let these long exponents fool you. We just have to simplify these exponents. Since they're so long, I really want to simplify them before even I worry about changing the bases. All right, so 3x plus, so I have, I'm just read this negative out, so I have 3x plus 2 minus 1 plus x equals 125. I'm going to combine like terms, so 2x minus x, that's x minus 1. I'm going to simplify this further. 5 to the 4x plus 1 equals 125 to the x minus 1. I know 125 is 5 cubed. So I'm going to substitute 5 cubed in for 25. So I have 5 to the 4x plus 1 equals 5 cubed times x minus 1. I'm going to do the product rule to multiply those two exponents out. So I have 5 to the 4x plus 1 equals 5 to the 3x minus 3. Now notice again, we've got equal exponents, so these are going to be equal. I mean, these two are equal to each other, so the exponents have to be equal. So we're going to set them equal. Then I'm going to get all my x's on one side and all my non-x's on another. It just so happens that x equals negative 4. So we started out with what was a long and complicated problem. We went step by step saying, okay, how can I simplify this to make it easier for me to work with? We started by saying, okay, those are really, really long exponents. So let's use our distributive properties and our simplification to make those exponents smaller. Well, okay, this still doesn't work. We need to let's make 125 in terms of 5, so it's easier for us. And then it was just standard using the rules of exponents, finding them equal, and then doing a bit of algebra to get our answer. And that's how you should approach exponent problem solving. I hope you found this video helpful, and I hope you have a great day.